Hello everyone, I want to welcome you for this lesson. I am Cairo Magutu of Chania Publishers. Welcome for today's lesson. We are continuing with the time value of money. The time value of money. The time value of money. This is what we are continuing with. In our last lesson, we did the introduction to time value of money. We looked at the present value of a lump sum amount and the future value of a lump sum amount. I want to take you to the third item. I will take it as item number 3, and this is the future value of annuities. The future value of annuities. The first question we need to understand is, what are annuities? What is an annuity? An annuity is an equivalent amount that is received or is paid from one period to another for a certain period of time. For example, the salary earned by an employee on a monthly basis is constant per month for a certain duration of time during employment. These are annuities. An investor may decide to make investment in annuities. For example, an investor may decide to be making deposits of investment at the end of each year for a certain period of times, of years. Like you can decide every year you will be investing 1 million Kenya shillings at the end of every year. We say that these are annuities. For the purpose of compounding, we need to ask ourselves, when you invest 1 million at the end of the first year, at the end of the first investment period, you will have the investment plus the interest. You add another installment. Every year you keep adding an installment. What will be the value at the end of the investment period? Let me explain this. When determining the future value of annuity or the present value of annuities, we need to consider two factors. Factor number 1 is that annuities may be realized or may be incurred at the start of the year or at the end of the year. To this effect, I will classify the annuities as, number 1, the annuity due, and number 2, the ordinary annuity. The annuity due, these are cash flows at the start, and these ones are at the end. For the purpose of compounding and discounting, we will assume that the cash flows are realized or they are paid at the end of each period. However, I will give the formula and explain the factors to do with the annuity due. That is, the cash flows that are paid or they are realized at the start of the year. I want to start with the ordinary annuity, and I will start with the future value of annuities or ordinary annuities. Future value of ordinary annuities. The future value of the ordinary annuities. As I have said, these are cash flows that are realized or they are paid at the end of each period. When determining the future value, I will give you the formula that we are supposed to use to determine the future value of the annuities. But before then, I want to make you understand what is the future value of annuity, making investment at each year. We see what will be the future value. For example, let us assume that an investor wants to start investing Kenya shillings 1.5 million per annum for a period of 4 years, earning interest at 10%. Suppose an investor wants to engage in an investment where this investor will be investing at the end of each year 1.5 million for a period of 4 years. This investment will earn this investor an amount of 10% per annum. How much is the future value? What is the future value of annuity? It is the cumulative annuities plus the interest from the annuities over the investment period. Let me put it this way. We have here year 1. Let me say it is the end of year 1. This investor will invest 1.5 million, like that. If this investment, let me put it here, year 1, this investor will say that invest 1.5 million. That is at the end of year 1. Meaning, in year 1, there is no interest that is earned. We go to the end of year 2. End of year 2. The end of year 2, this investor will earn 1.5 million plus interest, and which is 10% multiplied by the 1.5 million that he invested at the end of year 1, and this is 150,000. How much will this investor have at the end of year 2? It is the investment at the end of year 1 plus investment at the end of year 2 plus the interest from this investment, this one. This is 10% of this amount, 1.5 million. How much will this investor have? I want to use my calculator, although that should be 3.15 million. Let me give it 3.15. This is that 150. At the end of year 2, there is investment for year 1 plus investment for year 2 plus interest from investment at the end of year 1. This is the start of year 3. Now, another investment, end of year 3. This investor will add another 1.5 million. This investor will earn interest. Interest at 10%. How much is the interest? It is this one. This is that 150. That 150. That is 315. 10% multiplied by that 150. Like that. How much will this investor have at the end of year 3, which marks the beginning of year 4? The amount is, this is 15,000. This is 8. Sorry. Let me add. We have to add these 3. Let me put it in the calculator. I put it in the calculator. That 150, that 150, that 150,000 plus 1.5 million plus 315,000. This is giving me 49,65,000. Like that. This is what we have at the end of year 3. Cumulative at the end of year 3. Then we take end of year 4. This investor will have 1.5 million. We'll put 1.5 million. This investor will earn interest. Interest at 10%, which is 4,965,100. This one. This is 10% multiplied by 4.965. 4,965, like that. How much will be the total? This is the future value. Future value at end of year 4. Let us sum them up. We take 4965 plus the 10% of 496,500. 4965. Let me get it right. 4965,000 plus 1.5 million plus 496,500. This is 69,61,500. 69,61,500. I want to explain this concept because it is a very common concept in finance. We are talking of the future value of ordinary annuity, assuming investments are made at the end of each year over a period N. The future value here, we are saying that if an investor commits to be investing 1.5 million at the end of each year for a period of 4 years, this investor will make 4 installments. Year 1, another one in year 2, another one in year 3, and another one in year 4. The one invested in year 1 will earn interest at 10% at the end of year 2 because the investment is done at the end of year 1. No interest in year 1. It will earn interest in year 2. At the end of year 2, the investment in year 1 plus investment in year 2 will make up the total investment, but the interest earned in year 2 from year 1 investment will be available to earn interest in year 3. The process continues to the end of the 4th year, where we are saying that at the end of year 4, this investor will add another 1.4 million, another annuity. This amount will not earn interest because it is added at the end of year 4. What will earn interest is investment in year 1, year 2, year 3, and all the interest earned during the investment period. The total amount is what we call the future value at the end of year 4, which is the future value of annuities. It is very important to understand this concept. When you are evaluating a project, you may not compute it in these steps. What you do, we use a formula for the future value. We say that future value of annuity is equal to annuity multiplied by the future value annuity factor R% N, and the future value of annuity, I want to say that this is the future value of annuity. Future value of annuity. A I will say that these are annuities. The annuity. Then we have the future value annuity factor, R% N. This one I'll say that is the future value annuity factor at R% over N number of investment periods. N number of investment periods. The future value annuity factor, R% N, I want to give the formula, is equal to 1 plus R, this one power N minus 1 divided by R. This is what we call the future value annuity factor. Never forget this one. Always remember this one. How do we go about it? The R, this is the required rate of return. It is the cost of capital. We can therefore say that the future value of annuity is equal to the annuity multiplied by 1 plus R, this one, power N minus 1 divided by R. This is the formula that we use to compound the annuities. And I want us to do this. Our illustration here, 1.5 million is the annuity. Our R is 10% or 0.1. N is 4 years. Let us see whether this one will help us to arrive at this figure. That will help us to understand what is the future value of annuity. Let us go. Annuity is 1.5 million multiplied by 1 plus 10% is 1.1 power 4 years minus 1 divided by 0.10%, 0.1. This is equal to, I want us to compute this. Put this on your calculator so that we can get it together. I will put it on my end. I say that 1.1 power 4 minus 1 equals, divide by 0.1. This is 46, 41. This gives me 1.5 million multiplied by 4.641. Then this is equal to multiply by 1.4 million, 1.5 million, 6961. This is 6961500. 6961500. 6961500. Present value of annuity, where the annuities are ordinary annuities and which are paid at the end of each period. I want to explain the future value of annuity. We call them annuity due, future value of ordinary annuity. Can I explain the future value of annuity due? And since here I was in number 3, let me take number 3 to start for this one. I go for number 4. Number 4, I call it future value of annuity due. I want to demonstrate the future value of annuity due. The same way I explained here, so that you understand this concept once and for all. I want you to understand it and understand it, never forget about it. Let us go. This is end of year one. Annuity due are cash flows that are paid or realized at the start of the period. We say the start of year one. We invest 1.5 million. 1.5 million. Unlike the ordinary annuity, the annuity due cash flows are invested, or they are realized or invested at the start. There is interest in each year. We say that interest is 10% multiplied by this amount, 1.5 million. This is 150,000. This gives end of year one. We have invested. How much is the total amount? It is 1650. At the end of year one, there is interest in year one plus investment in year one. We make another investment. We make start of year two. We invest another 1.5 million. How much is the total amount? This one will give us that 150. Like this amount will add interest at 10%. That is 10%. Let me give it 10%. Multiply by 3.15. This is 315,000. Let me use my calculator so that we can get it very correct. The amount is that 150. Let me put it this way. The amount is that 150, that 150,000 times you add that 115. This is that 465. That 465,000. This investor will have this one at the end of year two. The investor will make another investment, start of year three. This investor will invest 1.5 million, like that. How much will be there at the start of year three? It is that 465 plus 1.5. We add 1.5 million. This is 4965. This is 4965, like that. This will earn interest at 10% again. We multiply by, we add the interest. The interest is 4965, like that. We add, this will give us 5461. This is 5461, 500. This is the end of year three. At the start of year four, let me put this one, end of year three. Then start of year four. Of year four. How much is it? Invest another 1.5 million. How much is the total amount to earn interest? I will take this one. Oh, let me put it correct. 5461, 500. We add 1.5 million. 1.5 million. This is 69,61,500. Then from there, this is at the start of year four. What is the interest in year four? interest at 10%. The interest is 696,150. I believe that is correct. We add, this is 69,61,500. We add the 10%. This gives me 76,57,650. This is the future value at end of year 4. End of year 4. They are called annuity due. They have a greater value compared to this because for this one, all the annuities are earning interest. For this one, the annuity at the last year is not earning interest. Let me give the formula like the one we have here. I'll say that future value of annuity due is equal to annuity multiplied by 1 plus R, this one power n minus 1 over R. Up to that point, they are similar with this one. They are similar, but you multiply by 1 plus the discounting rate. 1 plus R. How much is it in our case? It is equal to 1.5 million. We multiply by 1.1 power 4 minus 1 over 0.1. This one you put it in bracket. We multiply by 1.1 like that. It is simply what we did on this one. We multiply by 1.1, and I will not be long taking this one times 1.1. Let me see what it gives me. I will take 6, this is 69, 61, 500, 69, 61, 500 times 1.1. It is giving me 76,57,650. This is equal to 76,57,650. Is this not the same as this one? They are the same. That means I have explained the two concepts. The concept to do with the future value of ordinary annuity and the concept to do with the future value of annuity due. Anytime that you are evaluating a project, the first question you ask yourself, when are the cash flows realized? Is it at the start or at the end of the year? Once you understand that, you will know whether to use this formula or to use this formula. Having done that, I believe I have explained the concept so well. I want to leave this class at that point. Make sure that you revisit what you have done. Until next time, I wish you all the best. See you in the next lesson.